Okay, quick video explainer on how to do oxidation states within ions or even compounds. This is very similar to what we did when we did nomenclature with those compounds that had a Roman numeral in them. So you had to use what you knew about the charges, identify what those were, and then figure out what the metal's charge was and include a Roman numeral. This is very similar. So what we're going to do is we have a list of rules. You can check those in Drive, and we will use those to help identify the charges or oxidation states for those elements in a compound or an ion that we're not positive about. So let's start off with the sulfate. If we wanted to find out what the oxidation state, or sometimes called charge, is for the sulfur, we would start with our oxygen. We're going to know that oxygen is almost always going to be a negative or a 2 negative oxidation state. For us, that's always going to be the case. So if we have 4 oxygens and each one of them has a 2 negative, that's going to give us a total of an 8 negative charge. Well, overall, this ion has a 2 negative oxidation state. Well, so our sulfur must take care of and give us an overall charge for this thing of 2 negative. And we have a negative 8 or an 8 negative from our oxygens. So if we look at it like this, we have a total of 2 negative. We have an 8 negative. What value, in this case, that X is going to represent sulfur's oxidation state. What value of X would we need to have an overall oxidation state of 2 negative? And that's going to be a 6 plus. So this would be the oxidation state for our sulfur. Let's look at this chlorite ion. So the chlorite ion, we know that the oxidation state of the oxygen is going to be 2 negative. There are 2 of them. That gives us a 4 negative overall. Well, we have a negative 1 overall for the entire ion. So if we look at it as our chloride or chlorine plus our overall charge for the oxygens has to be a 1 negative, then this value must be a 3 plus, because that's going to cancel out 3 of those 4 negative charges and give us a 1 negative overall. So our chlorine is going to be a 3 plus. Now if we had an entire compound, we would go through and do essentially the same thing as we just did here, except we got a little bit more to deal with. So if I wanted to know, let's start off, what's the oxidation state of the chromium? Well, we already know how to do that. We know that our phosphate has a 3 negative oxidation state, and there are 2 of them, and that's going to give us a 6 negative overall. Now this entire compound is neutral, meaning that our chromium has to contain that 6 plus positive, and since there is only 1 chromium, that is the charge of the chromium. If there were more than 1 chromium, we would divide that up equally amongst those. But let's say we wanted to also know what is the oxidation state of the phosphorus. Now there's several ways you could approach this. I find that the easiest is, let's not look at this entire compound, but let's just look at the phosphate ion. That way we don't have to worry about that 2 negative, or that subscript 2. So if we look at this as just the phosphate ion, because the fact that this is in a compound formula and has a subscript 2, that's not going to change what the oxidation state of the phosphorus is. So if we go through and look and say, all right, I've got 4 oxygens, they're all 2 negatives, that's going to give me an 8 negative total for my oxygens. Well, the phosphorus is going to have to be equal to, so X is going to represent our phosphorus, is going to equal our 8 negative to give us an overall of a 3 negative charge. So this is our total. This -8 or 8 negative is from the oxygen. This X is going to represent what the phosphorus is. X would have to equal a 5 plus. And that then would be what the oxidation state is for our phosphorus.